Good morning. Today, from Lessons from the Clipboard, we are talking about lesson 8.7. This is surface area of cylinders. And so, just a couple definitions. First of all, we have the surface area, and we define that as the sum of the areas of all surfaces of a figure. And so, if you think about a cube, there's 6 sides of a cube. You would add all 6 of those sides up. And the nice thing about a cube is they're all the same. Then you have the lateral surface, okay? And that's the curved area of a cylinder. So if you take, for example, this is an old math review, if you take a math review like a cylinder, okay, this you can create into a cylinder pretty easy. You can see this in math review. And then enclose it by having something on the top and something on the bottom. Those two would be circles. And then this part right here, the actual math review itself, would be the lateral surface area. This is the curved part like this. Okay, and then you'd also add, for the total surface area, you'd add the 2 bases. Okay, now if it was for example, a prism, your lateral surface area would be very similar. Okay. So if you think about it, this is a triangular prism. It's a little bit tougher to see this one, okay? But you have the 3 sides that are rectangular. So these 3 sides form the lateral surface area, and then you have the triangle on the top and the triangle on the bottom that are the same, and those are your bases. And so the whole surface area is the 1, 2, 3 sides that are rectangular and the 2 triangles, while the lateral surface area is just those 3 rectangles. Okay. So today we're talking on surface area of a cylinder. So if you think about that, we have, and I'm not going to go into exactly why this is true. There's some really nice ways to look at it. Today, we're not going to go into it too much, but actually, I'm sorry, we are going to talk about why it's true. So first of all, you have the 2 circles, right? The circular pieces. So again, here's your cylinder. You have a radius, and you have your height. So surface area, you're going to have the 2 circles, which is twice the area of one of the circles, so it's 2 pi r. And then you're going to add this lateral surface area. Well, if you unfold it, you have 2 circles, and then you have this longer piece. Well, this edge right here, edge from here to here, is simply your circumference, 2 pi r, and then here is your height. And so you multiply those together, and you get 2 pi times your radius times your height. And so that's the surface area of the whole thing. So you want the shaded portion here, okay? So, easiest way to kind of look at it is to look at some examples. And so here's example 1. Okay, and remember, there's our surface area right here. And so find the surface area. And so I'll make a picture here. Sometimes you have pictures, sometimes you have word problems. We'll do a couple examples of each. Okay, that's your radius, and this one is, oops, let me do 4 inches, and your height is 6 inches. All right, so simply put, and in this case, I'm sorry, we want to use 3.14 for pi. Okay, and so make sure you have your calculator out. Let's hit this up a little bit. Now our surface area, S, is equal to 2 pi times r, which is 4 inches squared. And so you're going to see our units are going to be inches squared. And then we're going to be adding 2 pi, and then you have 4 inches times 6 inches. So again, here you have your units are inches squared. Now what I like to do is I like to get all the way through it, keeping it in terms of pi, so you're keeping it exact. And so you end up with an exact answer, and then you end up with your approximate answer. So 4 times 4 is 16. That's 4 squared. So 16 16 times 2, 32 pi inches squared, plus 4 times 6 is 24 times 2, 48 pi inches squared. So you see the units are the same. That's really good. So now we get 70, we get 80 pi inches squared. So that's your exact answer. And when you approximate it, so if we're using 3.14, it's not going to be quite as accurate, but it will give a fine approximation. So 3.14 times 80, and that is approximately 251.2 inches squared. Now, if I'd use pi, you'd have 80 pi. So we're off by a tenth. And so some of that is when we use an approximation, we want to think about, is this accurate enough? Okay. Let's go to our second example. Our second example is similar. Again, we're looking to find the surface area. So now we have one that's a little elongated, not quite as tall, maybe like a swimming pool type of thing, except that it is not quite big enough for a swimming pool. Maybe a swimming pool for ants or something like that. I don't know. All right. So we want to find the surface area. So again, we're going to do the same thing. Set it up, our S, our surface. You have the area of the two circles. So that's 2 times pi. Your radius, 15 centimeters squared. And then you have the rectangular piece, so that's your circumference, 2 pi r. 2 pi times 15 centimeters. Excuse me, sorry about that. Times 3 centimeters, your height. Again, we're using the formula right up here. And so let's start to simplify that. We get 15 squared is 225. So this time I'm going to write it out just because the numbers are a little bit bigger. 225 centimeters squared. That should be a plus. Oh. If you guys would have mentioned that during class, I would have given you extra points. And then you have 15 times 3 is 45, so that's 2 pi times 45 centimeters. And so that is equal to 450 pi centimeters. I was supposed to tell you to stop and try it on your own first. Hopefully you did that instead of just listening, and you'll make sure you're getting some information and trying these problems as we go along. And that's equal to 540 pi centimeters squared. And go back to the trusty calculator. Again, I like the graphing calculator. It sees things nicely. If you have one, it works great. And this is approximately 1,695.6. Again, the bigger your numbers get, the more error you're going to have. So be careful with that. And make sure you label your units. Okay. So the next one, I'm going to read it off. If you paid attention in class, you got the notes on this, and so you were able to see what the problem was. But it's talking about a cylindrical soup can. Okay. And so I'm going to give you the critical information. The cylindrical soup can is 7.6 centimeters in diameter. So our diameter equals 7.6 centimeters. And it's 11.2 centimeters tall. So our height is 11.2 centimeters tall. And so what you're trying to figure out is the area of the label that covers the side of the can. So I'm going to take and pause the video right now. I'm going to read the question one more time. A cylindrical soup can is 7.6 centimeters in diameter and 11.2 centimeters tall. What is the area of the label that covers the side of the can? So pause it and try this problem. Okay. So we're looking for lateral area. So we don't need the area, for example, of the circles. So our lateral area, L, is equal to, and that's just this second piece right here, 2 pi r h. 2 pi r h. Well, from this information, I want to get r equals, and that's 7.6 divided by 2, which is 3.8 centimeters. And so I'm going to multiply this out. 2 pi times 3.8 centimeters times 11.2 centimeters. Okay, so I'm going to multiply this all out. I'm going to leave it in terms of pi, so 3.8 times 11.2 times 2, and that gives me 85.12 pi centimeters squared, which is, in this way, case studies approximately, times 3.14, 287 point, and here you can see I'm going to round it to the nearest hundredth according to this, so 28 centimeters squared. Okay. So we have one more problem that we're going to do. Again, I don't have it all written out, so I'm actually just going to read it for you. This is example 4. It's our last example. And again, we have a cylindrical storage tank that is 6 feet in diameter and 12 feet tall, and it needs to be painted. The paint will cover 100 square feet per gallon. How many gallons would it take to paint the tank? All right, so we have, I'm going to put down 100 feet squared per gallon. So we remember, and we're asking how many gallons. So how many gallons? Okay, so the diameter is 6 feet in diameter, and it's 12 feet tall. So H equals 12 feet. All right, take and try the problem. You know that you have the diameter, you have the height, you can figure out the surface area. Okay, all the sides are going to be painted, not just the lateral area. And so how many gallons will it take? Take and try the problem. Stop the video, please. Okay, so hopefully you tried it, and if you did, the first thing you need to know is the radius is 3 feet. And so our surface area is 2 pi r squared plus 2 pi r h. Okay. Now, if you only have to do one circle, for example, you're not doing the bottom of it because it's something that's on the ground, well, then this would just be 1. So you have to think about what your surface area means. Okay, 3 times 3 is 9, so that gives you 18 pi feet squared plus 36, so that's 72 pi feet squared, which is equal to 90 pi feet squared, and 90 pi, I'm just going to I'll use 3.14. Some people like that. I like to do it a little more exact, but it just depends on what reason I'm doing it. So this is 282.6 feet squared. Now the question isn't how many feet squared is it? It is how many gallons are we going to use? Well, obviously we're going to use 2, but then we have a third gallon. So we're not going to use 2.8 gallons because, well, you don't buy usually 0.8 of a gallon. You can get half a gallon if you wanted, but we will use 3 gallons, or we will actually buy 3 gallons of paint. Now, again, it depends. If you had like 300 of these things to do, or like 10 of them to paint, then you're going to look at 2.82 gallons. So this, you could say this is actually 2.826 gallons, and that would be okay. Here's a case that if you had to round it, you're going to round it up a little bit, so I'd go 2.83 gallons if I had to round to the nearest hundredth, okay, of a gallon, or if I was to the nearest tenth of a gallon, you're going to have to round it up, because if you put 2.8 and you only got 2.8 gallons, you're going to miss a little bit, okay? All right, so your homework, actually just exit slip first, and you can show this to your teacher. And it's find the area. So we have 3 inches here for your radius, and your height is 14 inches, and your homework is 8.78. So finish up your exit slip, show your teacher, and then do your homework. And by the way, I will write out your homework for you because it is page 429, 1, 5, 9, 11, 21, 23, 25, and 27. Remember, on your homework, You can check the answers in the back of the book, but you do need to make sure you show your work or you will get very little credit. Thank you very much. Have a great day.